Alrighty guys, let's pick up from our last time that we met. So in the previous video, I just created a J panel to set up my window, and I created a renderer to actually produce my graphics onto the screen. Then after that, we went creating some utility functions that define the coordinate in 3D space, grouped them together in groups of 3 to form the surface of a triangle, a collection of triangles to form a mesh, and then some utilities to perform some operations on to project this 3D dimensional data to a screen. So there are a couple of things that I want to address. The first thing is from the last video. I have went and I noticed some changes while watching the video to these four methods. I believe that I implemented the cross product wrong, so I went to go and fix the formula here from the last video and some other things. Besides that, I don't think there was anything very wrong with anything that I've done so far. So the last time that we were here, the frame rate may be bad, but we essentially have our cube now. As you can see on a normalized screen space, perfectly almost in the middle of the screen, rotating around. And so essentially what we're going to do today is we're going to get the surface normal information from the cubes to determine what we should and should not be able to see using our utility methods that were in the Vec3D class. So that is essentially what I'm going to be aiming for on today's video, while also implementing a 3D camera. But before I get into that, I guess I want to talk about this cube is there are certain things that we obviously should not be able to see. And so what we're going to do in order to remedy that, to tell our rasterizer what we should and should not be able to see, is based on what I said as normals. And essentially what a normal is, like in, if you ever have taken a physics class, is that it is a imaginary line that is perpendicular to a plane. And then so essentially what we're going to do is using the cross product, which is going to take two intersecting perpendicular lines, and it is going to form an imaginary line that casts outside of it. And so essentially what we're going to say is that we're going to create a temporary placeholder for implementing our camera that's going to be centered at the origin. And we're essentially going to say, if these two like 3D vectors align with each other, then, or based on its direction, we should be able to see things, and we shouldn't, and we'll determine which of these lines we will draw and won't draw. And that's how we're going to manipulate our rasterizer to tell us what we should be able to see based on that normal information. So for that, one thing I do want to do is I want to go into the triangle class, and I want each triangle to have a color. And I'm going to create a method here that is going to take in RGB values and then return a color to me. New color RGB. It's going to return that color. And before that, I actually want to go into my mesh class and finish coding this load object from file method. So essentially what we're going to do is that I'm going to create a file reading method that is going to take in OBJ file data, which is mainly for now going to be the triangulated surfaces. So it's just going to be the vertex information and the face information, not the texture information yet. Still having trouble with that. So we're going to want to have a list of triangles we're going to call tris. It's going to take in a list of Vec3Ds. We're going to call them verts. Going to also take in two file names, one to handle the vertex information and one to handle the face information. Now you may be saying, why don't you parse the files better in order to be able to grab them at in the same file? Well, I went into Notepad++ and I've conveniently figured out ways to, for example, just do this. So if I did Control F, I can replace things very simply with / get rid of all these empty spaces, get rid of the F's, and put them into different files relatively easy. It's more work, but I'm not very advanced at file parsing and using string tokens and things like that, or splitting. So I've figured out a way that works for me. Again, this isn't a tutorial. This is definitely a learning process for me, and this is what worked best for me, is what I found. So I'm going to create a file, new instance of a file, and create a second one, file 2. Oh, do not call it file name 2. Oh. So we're going to create a scanner object. Initiate the scanner class to read through our file. So we're going to create one called file. I'm going to create a scanner called scan2. I realized that I misspelled file wrong. Okay, yeah. Let me wrap this up in a try catch block, because I don't feel like actually throwing the file not found exception. Trace. Oh, please do it automatically for me. No. Fine, I'll do it myself. Okay. Just tap this out real quick. Okay. So now in our first scanner, we're going to say while scan.hasNextLine. Going to want to grab 3 floating point values. So we're going to say, or double precision. We're going to say double x is going to be equal to, and that next double. I'm going to say that our y and that next double, and then our z and our next double. I'm going to set these to negative to flip them, because when I triangulate my faces, I always forget to do this, so I'm just going to do that. 3D X, Y, Z. Close that. Least access from the file, and then file scan2.hasNextLine. Base values should be in pairs of 3, so we're going to say the integer array, we're going to call f to represent base values. So it should be scan.nextInteger. Say f of 1 equals scan.nextInteger. And say f of 2 is going to be equal to scan.nextInteger. And then so we're going to say that, what I call it, tris. Add new triangle. Hertz.get f 0 minus 1. Hertz.get f 1 minus 1. I don't exactly understand too much of the logic behind mapping the face values like this, but because of a tutorial I watched, they said that this works, so to me, I mean, it is what it is. I mean, I just get accepted for fact. Okay, so now I already have a comment here that says stationary position vector that will serve as the camera, which we're going to define as vec3d. The camera is going to be centered at the origin. So this is going to be just simply a new instance of the vec3d. Our camera is simply going to be a stationary coordinate based on our plane, and we're not going to implement anything camera related. But first, we need to, after we translate, but before we project anything, I'm going to say that this is going to collect the surface normals and see how much they map over the camera. In order to do that, we're going to create 3 new vec3ds. I'm going to call this one normal, which is going to represent the normal that we're going to get from the next 2 vec3ds that we're going to define, called line 1 and line 2. Line 1, I have to initialize them before I could use them, so bear with me here. Say line 2 is going to be equal to new instance of vec3 class. Cool. Okay, so like I said, about the perpendicular lines, we need to get 2 perpendicular lines. So in order to do that, we're going to say that line 1 is going to line 1 dot, I'm going to subtract try_trans dot vec3d2 minus the translated triangle of this vec3d. And line 2 is going to be very similar, so line 2 is going to call the subtract vector method, and it's going to use the third one and subtract it from the first one to get the perpendicular lines. And so all our normal essentially is going to, like I said, utilize the cross product to find that normal. So we're going to say normal is going to be the cross product of line 1 and line 2. And then we have to normalize the normal to make sure that it's a unit vector. And so after we do that, we can essentially say, for the time being, if that z is less than 0, meaning pointing towards us, we want to draw those triangles. So we're going to grab everything from our drawing routine. Put it to these sectional lines, and boom. Okay, let's see what it tells us. And there we go, that already looks much better. So there's a small discrepancy. We can still see some lines that we shouldn't be able to see. And the reason for that is actually fairly simple. This is not taking projection into account. So you should really go and watch One Lone Coder's video on it, because I'm only really going to explain it briefly, because again, this is not a tutorial. The real danger of trying to form a 3D engine of my own is yet to come. Is essentially the way that the ray is casted down to determine the surface normals. There's a small discrepancy where we're not checking to see how much one line is projecting upon another, which is essentially why we need to use the dot product to really get rid of this last discrepancy. So I'm going to create a vec3d that I'm going to call vCamera. Just initialize real quick to 0, 0, 0, and essentially vCamera is going to be the difference between each triangle's first vec3d and then the camera. And so what we're going to say is that we're going to take the dot product of and then we're going to want to see how much is the surface normal of each triangle projecting upon this vCamera ray, which is just going to be an enhancement of our camera. So I'm going to define this as how much is each triangle's surface normal projecting onto camera. And so once we do that, oops, Oh, I must have made an oopsie somewhere. Oh, I forgot. This should be camera, not V camera. What am I doing? There we go. This should handle that final discrepancy that I was discussing. And now there shouldn't be any weird things drawing now. So now that our cube looks to us as it has been filled, so to say, there's one more thing that we want to be able to do for any sort of 3D engine, and that is to be able to color this. So here's what we're going to do. In order to color, I'm not sure when I'll take this, but I'm essentially going to first I'm going to define gonna use the polygon class called triangle. I'm gonna set it to be equal to new polygon. Again, when I was trying to figure out, because I'm not using the same graphics API or the same standard graphics library as the tutorials I was finding. So essentially, I'm going to use the polygon class to fill the object for me, given certain points. So I'm going to say triangle dot add points. So try projected dot vec3d dot x, and then try projected dot vec3d dot y. I need to identify these, I guess. Your values. This should just be approximate, so this shouldn't really cause any major problems. Two and three. So yes, the polygon class, I'll essentially create a polygon object, add all of its vertex information for the x and y, and then I can just use the fill function in the standard graphics library to fill it with a certain color. So now we need to get a bit into what lighting is. And so there are many types of lighting, and the one that I'm going to implement now for simplicity for now is going to be called directional light. And essentially directional light is that it is going to be a coordinate, a direction, so to say, in our world. We're essentially going to say that, again, using the normal data and the dot product to figure out when these surface normals align with this, 3D coordinate for the light, I'm going to assign it a color value. So I'm going to call this, well, actually, I don't really need to do this here. I can do it on an as-need basis. So I'm not exactly sure where it would be. I don't want to look too intensely at my notes, but I will to make sure that I know where I should be doing this. I can just do it here then. I'm going to create vec3d called light direction, and I'm going to set it to only be along the z-axis. So I'm going to set it to 0, 0, -1. It's going to be 1 unit behind the player. So this light is going to be behind the player. I could put it on the Y above the player. I could put it also along the X, but I just want it to be behind the player. Since our camera is very primitive right now, so let's see, how do I want to define this? Directional lighting behind or I can say that specifies a direction. where light jet from. So now we're going to normalize the light directions. It's going to normalize the vector, normalize it into our screen. Then we're going to calculate the dot product. Again, seeing how similar two lines are. So I'm going to say dot product is going to be equal to, again, before I did the absolute value, because sometimes the dot product can slip below 0, but I'm just going to say math.max, choose between 0.1 and then line and the dot product of that light direction. And then the normal, I believe. That should give us a value. So simply do the fill triangle. We're going to draw to it. It's going to drive me crazy if I don't do this right now. This is something that must happen. I should have just used a command to do this. Okay, that's fine. Everything is lined up now. Okay. So how are we going to set the color? So we're going to actually give each triangle a color. So we're going to say it's going to be equal to new color. That's going to be base EP's value. Right. Integer file this approximates. Now let's see what this is going to give me. Well, it's a completely white cube. The shading is not completely correct. So it means that this DP value that I'm getting is not exactly right. I may have forgotten an intermediary step. I think I just needed to normalize it. Right? And I just needed to take dot product, difference between the light direction and that normal. I'm actually going to go to this and make sure that's correct. Not exactly sure if that's what it was. Pretty sure that's what it was. Yeah, normalize it, take the max between light direction and normal. Did I normalize it? Make sure. Yeah, I normalized it. Afterwards, DP, the max between 0.1 and light direction and the normal. Okay. Set the color at. I guess I still have to call the absolute value of it. I guess it's still giving me some unwanted values, so to say. Again, because I integerified it, I think that 0.1 is definitely rounding to 0, which is a problem. Let's see if this works out in favor. Okay, let me do something real quick. System up. Value DP, so I can have an understanding of what's going on. Mm-hmm. Mm-hmm. So define the slight direction. Normalize it. Have one more good look at that. May have still managed to somehow do something slightly wrong. Gotta think about this. So here, let's compare this. Vector decall light direction. Here's your -1. Normalize it. That makes 0.1. Then product normal, right? Let me check something quick. Make sure I'm not like major tripping right now. See if calling it in the method will actually help me out instead of just automatically accessing the data member. It's actually not helped me much at all. This is, I cannot believe almost doing the exact same thing over again is causing me this much trouble. Again, I'm working on this class to like do things ahead of time. Or this was what I was working on and what influenced me to do this. And then here. Oh, I'm forgetting to set the color. Oh my god. Is that what's happening? Try color. And there we go. That has, for the most part, fixed my issue. Ah, okay, that's going a bit fast there. I want to see it a bit slower than that. Now that this is what I actually want the lines black for a second. Go. That was an embarrassing mistake, but we're here for it, man. I'm here for it, man. Once I set the color, I call the method. I actually have to set each triangle's color before I fill in each triangle. Alright, now that I'm fairly certain that that's working. where put you back to being 0.02. And there we go. Our light direction is currently working. The more that our surface is aligned with this camera that we've defined, it should be currently working. Now, I actually want to define a mesh. So, go on my files here. This is my project for my class I did today. Let's not look at that. Let's go to borrow this. I actually want to borrow the Bowser, right? Copy those over to this project. Paste them here. No. On the initialize mesh, we're going to do it here. So I'm going to create a list. Array list. I'm going to create a list that creates converts just like I said. This. Now we're going to call that. Do I actually have a matrix in here? Was it in mesh? I think I can call it object from file. First one is for the vertex information, so that's just going to be browser.txt. fbow. fbow. Comment this out for a second. Simply going to say that mesh cube is going to be equal to a new mesh that's going to be populated with these triangles. Let's see. Okay. Cannot invoke this dot mesh. Let's create a new constructor for the moment. Say that mesh m. Whenever I want to call this, it's going to be equal. Actually, just going to call it m instead. Yeah. Call m. Now let's see if this works. Not work. Why? System cannot find. Oh my god, fbow.txt. Please let me stop being dumb. Now what? Scanner closed, of course. Okay. Scanner closed. Well, of course I closed the scanner. I didn't need it anymore. Fine, I'll close it here. Oh, fine. You know what? Wait. Where did it give me this time? No such element exception. I see. Well, I'm just going to grab this automatically from here. I do not have time for this. do not care enough. So call this browser.txt and file. And then I'm going to say mesh cube will be equal to a new instance of mesh class filled with triangles. No such element. Again, I'm gonna go check these utility functions that I created. I don't think I finished it in the last one. I think I just had it sitting in game panel. Yep. Ah, I see. Oh, let's copy this real quick. And I'm just paste it. Then I'm going to uncomment it. Let's see if that works. Oh, all right. I don't know what was the huge difference between what I did before and then, but I guess I think I did everything almost exactly the same here, except for this little piece where I did vector dx explicitly equals these things. So I'll keep that in mind and try and research why that happened, why that little difference somehow managed to allow this to happen. Now I'm going to try and call that method because I don't want all this in my face like that. M.load object from file. .txt with f.txt. There we go. That should be working. Okay, so where I translate this at? Let's put this bad boy at like 60. He is a very big boy. Okay, so now the next problem that we have here is that we see things overdrawn on each other. And so, since I haven't gotten texture mapping to work, I'm not going to create a vertex buffer. Essentially, what I'm going to do instead of a vertex buffer, since I can't implement that yet because I'm still doing my research on texturing without using any graphical APIs, just using the standard graphics library from Java, is we're going to essentially create a sort of painter's algorithm. Essentially, we're going to take the z value of each triangle, of two triangles at a time, and essentially draw backwards to front. So we're going to use the comparable interface in Java to compare our triangles and sort them based on the criteria. So I'm going to create a list of triangles called call them triangles to raster. Alright. So here, I think all we need to do is grab this information, cut this for now. We're going to add these to the triangle. Oops. So here, triangles to rest. Add, try, rejected. So now that we have this, we want to further specify what we should and should not be able to see on the screen. So how do we decide this? So what we're going to do is that we're going to create, I'm going to call collections.sort, say a list of triangles. It's called vec triangles raster. Your new comparator. Here it's going to hold triangles, so the comparable method won't know to compare triangles. And so now I'm going to add going to override the compare method, not compare to, we're just going to do compare, because we're going to set the criteria for the compare. We want to compare a triangle called T1, a triangle called T2. So it's going to take two triangles at a time. I'm going to take the C1 is going to vec3d.c t1.2.z plus t1.z divided by 3. Z2 is going to be equal to the accumulation of the values T2. Copy this. And I'm going to set all these T1s equal to T2. And so now what I want to do with the information, well, I want to return if Z1 is less than Z2, I'm going to want it to return 1. And then Z1 is using logical operators, so if it's equaled to, I want it to return 0. Otherwise, it can just return -1. Just imports. Give me an error for this. Let's import the collections and the comparator for me. Really should be here. There just need to be a list of triangles. have it set here. Yes. Not that and fix it. Again, always having to hate to come back and check here because it makes me feel like I don't know what I'm doing, even though this literally shouldn't be any different. Type anything wrong here? Oh, it's outside of this for loop. Like how this has not solved anything. Let's go back to game panel. Let's figure out. So when is this calculated? We have I don't see why this is apparently giving me this trouble. And just like that, it's done. What did I do that was so wrong? Oh, it wasn't wrapped around in this little block. I see. Okay, I see. It's supposed to be wrapped up in this little convenient block. Okay, so now that these have been sorted based on that, I can now create another for each loop. So I can say for each triangle T, that's going to be invet triangles to raster. I actually got rid of that fill code before, so I think I actually have to retype that. It should be easy. Let me see. What did I do first? So, draw triangle. X, Y, X, 3.y. Need a pass G2 into it as well. And now, after set the color, I want these on lines to be drawn to be black. I'm going to redefine my polygon here. Triangle, polygon. Triangle, add point, dot x, dot x, 3D dot. Hit me too. integers. I'm gonna make a rule. I'm gonna try to not go back to figure out what's going on in the Arcade Chronicles, because I need to make sure that, you know, this is like legit me going through the process. If I can't figure out something on my own, well then what's even the point? Because I have a lot of harder things out there for me I forgot to fill. Right. It needs to be filled. It needs to. Okay. Ah, I see. It's being drawn to the screen. Set this to white real quick. Okay. The coloring information wasn't passed over. So the absolute value. Paste. Set this back to black. That should be fine. And there we go. For the most part, that's fine. There's still some slight discrepancies that are annoying me, but for the most part, this is fairly decent. There's not a huge amount of overdrawn going on, but you could see like very slight things being drawn over, like in this little corner right here. But hopefully once I create my camera, things like that will be a non-factor. Let's see, how long has this been going on? Around an hour. I actually want to go back to my handy dandy cube for a second. I'm gonna comment you out. I'm gonna comment this out real quick. Fix imports, please. Yes, okay, well, I'm gonna need you to be a bit closer than that, my little cube friend. It's been translated up here somewhere. Let's get you to be 16 units away from us. In depth. Yeah, and this is fine. My FPS is kind of screwing things over, but so far this is fairly decent. The next thing to do would be implementing a camera and then working on clipping. So anything that isn't drawn onto the screen, making sure that we are not drawing that onto the screen or rendering any of it, and adjusting our triangles accordingly. And that is essentially all that I know about 3D graphics programming in order to create a 3D engine. After that, everything will be me improvising to sort of figure it out. So I can't wait for that. I guess I can start working on a camera. So essentially there are two ways that you can think of a camera. So in 3D, when you're talking about implementing a camera, there are two ways to essentially do it. There is moving the world around you, where based on your user input, you shift everything in the world certain units to give the illusion that your character is heading closer to it. When your character does not move, everything else is moving towards you. Or what I'm gonna do is what I learned is that I essentially take this stationary camera that I've set up, and I essentially move this camera around the world and then everything will sort of adjust based on that. And so that's essentially what we're going to do, is that we're going to create what is called the look at matrix. And because that would take long to code, I'm going to show you what that is so I can explain it a little bit. Though my understanding of it is very faulty. I think it should be in vector. Okay, now that's for clipping. Should be in matrix then, right? Yes, so essentially we have, and I'm just going to copy this simply because it'll take me a really long time to type out, and these are two things that I've used as black boxes. While I do understand the point at matrix, the look at matrix, or the inverse matrix, I do not know how to derive an inverse matrix to save my life. I'm not even going to pretend like I understand how an inverse matrix works. I just know the rules for it. I know that this is what it's supposed to be. Get rid of these. I do not have that mysterious fourth dimensional element right now. I'm not really worried about it. Okay. We'll worry about that fourth dimensional element in a second. So this is essentially the point at matrix and inverse matrix. Now I have in my notes explaining to me essentially what the point at matrix is and what it's attempting to do. So as I explained before, there are two major ways to think about how to move around a camera, or how to have the effect of a camera. And I wanted to develop a first-person shooter style camera for the Silent Hill clone game. And I'm also going to develop a sort of orthographic projection camera that is going to basically, because Silent Hill had a lot of weird camera angles, so I actually need to define a lot of cameras, but this is the one that we're going to use for now for developing the engine until we need to worry about more advanced camera angles. Essentially, instead of using trigonometry, we're going to be using linear algebra to define where something based on rotations should exist by defining new directions. So essentially in our input, we have our position vector, which is going to be our camera, where we want to go, and our up vector. So to define our new forward vector, where we want to end up going, we're going to take the difference between the target and the position vector and normalize it to our screen. And yeah, I have some explanations here for what this is. And this is essentially the look at matrix that I have defined in my little tablet. So let me come back here. So I'm going to create a vector that will be moving around. I'm going to call it the look at direction, which is going to be our target direction. I'll define it in a second. So I'm going to come here. So I think I can do it around here. Should I do that? Doing them after all of our translations should be fine. So essentially we're going to say that we're going to define our up direction is going to go along the y direction. So I'm going to say 1, 0. For target direction, going to go along the z-axis, and then here's where we can the matrix. We're gonna call matte camera rotation. Initialize it. This. I think I've already defined the matrix, right? I think I called it M. I need to call the rotation in the Y direction. Is that what it was called? Oh, that was a mesh. I have defined a matrix. It was right. It was matte. Okay. So rotation matrix Y. Put an angle called F yaw. I'm going to define F yaw. So there's yaw, pitch, and roll, which is talking about the rotations in the X and Y and Z directions. Let me define my look directions. Camera direction. Then I'm going to say rotation around y-axis for the camera. It's the convention to call these yaw for the y, and then there's pitch and roll for the x and z. But we just want to rotate in the y to get our first person shooter camera to be working. So back here. Now going to define our look direction. So our look direction is going to be matrix multiply vector. The camera rotation that we just got. And then our target vector. Let me, again, need to go and check here. I definitely should be more aware of what's going on with the camera. I'm just going to borrow all of this. I'm not even going to hold you. Okay, so now that we have our up direction, our target direction, we've defined our rotated camera. I forgot that I needed to actually, the matrix needed to go before or after the vector. And so after that, I have matte view now. have this intermediary step after the dot product. Let me go and define what that is. For this, it's on my nerves. So here, copy this. Try viewed. Now we're gonna have an intermediary step. We want this. Try viewed now. Projected. And this should essentially look exactly the same because I haven't done anything with the camera yet. So I actually need to go, I forgot to do this. I need to go and get the keyboard input. So let me open up key handler. So let's do this. So hit key code. Key event. A. So if you click on A, I'm going to essentially say that up press, left press is going to be true. Key code, key event, A underscore P, I'm going to say that right press. Oops, not using logical operators here, just assignments, okay. Get code, key event, space, say up press. So if we code equal to event.vk underscore c, I'm going to say that is going to be down press. And so in order to go forwards and backwards, so if you click on W, I forgot what I called it. I call it front. What did I call it? Yeah, front press. There are a lot of keys I know. So if you get code key event vk underscore s, I want back press. And to be able to turn into our world, let's say on Q, say right, wait, no, let's left. Click on E, it'll be a right turn. These are gonna be what we're gonna use for a while. Again, I need to set that once this key is released, these will be equal to false, or else they would be true indefinitely. That would be bad. Okay, so now that we have all of this, now we need to go and get some keyboard input. So that's why I had this update method. And this is going to handle our user input. So we're going to say if kh dot left press is true, I'm going to want camera's x direction minus 0. Yeah, x direction. And so then if h dot right press is want should be minus. Let's check to see if that works. Go. So we're gonna say if ph dot up press, I'm gonna want the y position of the camera decreased by this. Then to be down pressed, what happens to the y? So here, down press. Go. Left, right. Sorry if my frame rate is dropping. Left, right, up, down, left, right, up, down. Okay. So the next type of input that we're going to want is going to be to see if we can move from front to back. And essentially what we're going to want to do is we're going to take that forward vector that we have, you know, where we want to go now along the z-axis. So this is just working on incrementing the size, the depth value, I guess, and increasing that. So it's sort of almost like a translation. So we're going to create a vec3d called v4, which is going to represent the forward direction. Vec3d. Let's initialize it 0, 0, 0. Then we're going to say that v4 would multiply vector by that look direction and 1. It's just constantly, making sure that's what's happening. And so if ph dot front press, I'm gonna say that v camera is going to equal to v4 dot add, so it's going to add that now. It's going to add camera v4. And then so the opposite is going to be true if we want to move back. It's going to call a subtract vector. Right. So let's see if that works. Cannot read field X because N is null. N is null. Null point exception. Here. Ah, it's because I haven't defined the look direction yet, huh? Let's just define you as that for now. Here we go. Go. Boom. And so to turn, or to get the yaw, it's going to be, again, a little bit more complicated, but essentially all we're doing is changing that yaw value. I'm going to say if the h.right turn, it's going to say that f yaw increment itself by a very small amount, simply because my game loop calls this 60 times per second, so it can get very bad very quickly if I add too much onto it. So I'm gonna say f yaw minus equals 0.008. I think, and it's very hard to tell with this cube, so I'm going to go and comment out the cube for a second. I'm going to go and bring back this. Alright, don't even need to translate that bad boy. Oops. So really, I don't really need him rotating anymore. So where's f theta? I can just keep that to be 0 for now. Hello there. Back away from E. That's all working. Up, down. And of course, because there's no clipping going on, there are some problems that I'm having with doing this, but overall, this is fairly what I expected to happen. Ugh. Yeah, it's gonna be a bit weird, but overall the basics are working. I can go up, down, left, right, obviously down, up, turn this way, turn that way. I am a bit concerned with code. I'm gonna go and check it with the original and make sure that that was a problem that I remember having. I believe that it was. Yep, here, make sure I did this right. Yeah. Yeah. Mm-hmm. And I basically copied everything for verbatim, including the camera matrix and then the inverse matrix matte view. I've tried projected transviewed. Scroll down here. Not going to get into the clipping, but once I do clip, I think what I'm having with my camera won't be a problem. I think this is more of a problem with that. Yeah, I got this camera working. Go here. Oh, this, can take it as a black box, but I do understand how to derive the point at matrix. The inverse matrix, not even a chance. I still need to learn how to derive all of these though. The fact that I had to copy and paste them, not a very good sign. Need to make sure I go and study that. But I have all my notes and I've been watching the videos, so that should be a bit of a problem. Just checking to make sure that there wasn't anything else I wanted to cover while I was here. Oh, right. I'm gonna set this up another constructor. So I'm gonna get my 2D coordinates, my UV coordinates. I'm ready for next episode, or next video. I shouldn't call them episodes. Copy this over. Back. B3. I want to create a constructor for now where I can just initialize my Vec3D instant variables, and then one for once I want to work for my texture coordinates. Once I figure it out, I can also initialize Vec2Ds as well. Now, the reason why I'm not going to implement clipping is because it's something that I've learned relatively recently. I'm not terribly sure how it exactly, how the methods work yet. I'm still studying them and making sure I understand them. So before I do come here, I do want to make sure that I have a fairly decent understanding of what's going on. I want to implement the clipping, and after that I'll basically be on my own because I'm currently trying to figure out how to do texturing for texture mapping, and I've come to a happy medium with using this website that talks about buffered images. I've been watching some videos online. I don't want to have to use a graphics API like OpenGL, but I'm also not turned off to the idea either. If push comes to shove, I'll definitely do it if it was absolutely necessary that I did so. Find it up until a certain point where so definitely cut out on me if I get too close to it on the Z plane. But this is Bowser, as you can tell. So once I get clipping, I'm going to come and read this and try and implement this for myself live. This is the first thing I'm going to do texture mapping, where I'm pretty sure by the time I get the clipping working and getting the clip plane set up, and once I get that, the only thing that I'll be moving forward with is figuring out how to do this texture mapping, because all of my tutorials basically go up with they go through teaching you about the basics of 3D graphics programming, about projection matrix, culling, the normals, the cross and dot products, all the utility functions I've been doing, all the way up until the cameras and the clipping. And after that, I'm basically on my own to shift from tutorial to tutorial, website to website, to try and figure out what I need to do. So I guess the next video, unless I decide, how long has it been? Hour and 24 minutes. I think I'll call it here. I think I'll implement clipping the next time. But so far I'm pretty happy with how much I've progressed and how I relatively didn't have to cheat in order to do this. I understand almost everything that's going on here. This implementation of the collections.sort is very weird for me, because let me show you my class project for a second. So I'm more used to doing where it implements the comparable, it takes the class input parameter, and I used to compare two method to override. So I actually had someone help me out on the One Lone Coder Discord server. Great Discord server. I recommend you go there. There's so many helpful, lovely people there. And most of the problems that I've had, they're helping with. They're currently helping me with texture mapping as well, but I'm deciding to be a bit proactive as well and trying to figure out the problem on my own. So the next episode, it shouldn't take me very long once I study everything and make sure I know what I'm doing to implement clipping, and then I will literally be on my own, so that'll be fun. Last thing I guess I want to grab. Actually want to grab these two. I'll do that. Go and paste them here. So x-axis and f-axis. This is gonna help me get one long coder provided this way. What? What is it doing? Oh. Oh. Okay, so this coordinate system will help me understand what's going on. And up, down, left, right, and I can turn. My turning, I realized, is backwards because this one is different from the Bowser. So all the way back here, set these to be negative. I'm actually not going to do that in a second. Oh, the Y must be flipped. X must be flipped. Let me see what happens if I unflip the X. Oh, I see it inverts. Okay, so now I was right. I'm gonna swap these then. That should be fine. Moving around in the world. A very slow pace because I'm not turning awfully much. Here, turn. Very slow turn, but here we are. If I get too close to this bad boy, yep. A lot of memory management errors, a lot of bad things happen. So that's why we're gonna implement clipping and texturing. And then once we do texturing, we'll start working on what you see, game objects. So creating so desktop. So here, so implementing, shapes, giving it an origin point, a width, a height, and a depth, and, creating algorithms for a sphere, a cube, triangle, prism, 3D pyramid, hexagonal prism, cylinder, star pyramid, all these objects. And so we can use that as the building blocks, for the vast majority of the shapes that we're going to use in the game. Since I do want to, for the most part, use my own shapes in order to form objects. So yeah, I guess I'll call it here.